Relapse normally occurs when an individual starts to feel stressed or by being in the environment in which one would usually consume alcohol. Dopamine is a signaling molecule associated with identifying rewards. For example, when you eat your favorite meal, your brain will receive dopamine to tell you that this was an extremely rewarding meal, causing you to feel motivated to eat it again. This is what happens when you consume alcohol. However, over time, this dopamine increase does not actually happen at the moment of alcohol consumption. The rise follows a presentation of specific cues that would normally lead to alcohol consumption. As alcohol is consumed more and more over time, the alcohol itself is not necessary to release dopamine. It's actually the cues associated with drinking that cause the spike. For example, entering your favorite bar will cause the increase of dopamine release. So, what's the problem with having too much dopamine? The problem here is what happens to your brain with chronic exposure to dopamine. Dopamine causes changes in the brain that enhance reward to alcohol while reducing the response to normal rewarding activities, like that one meal you really loved. Not only that, but the morphological changes in your brain may also lead to increased anxiety and sensitivity to stress. After a certain point, alcohol will no longer reinforce positive effects, but eventually it will be used to eliminate negative effects. There are many areas of the brain that undergo morphological changes due to alcohol consumption that increases dependence on alcohol. Our brain is made up of gray matter and white matter. The gray matter controls our muscles, help with hearing, sight, memory, emotions, decision-making, and self-control. The white matter connects gray matter to each other and helps speed up the process of sending signals. The brain of a chronic drinker undergoes many changes. For example, the individual's white and gray matter is reduced in size, specifically in the areas that help you control movement, balance, and memory. So overall, the brain size shrinks. But what happens to the brain when chronic drinkers abstain from alcohol? The damages from alcohol slowly improve. Binge drinking decreases the number of cells in the brain, impairing brain function. But upon 24 hours of not drinking, the cell numbers start to increase. 48 hours after binge drinking, there are bursts of new cell formation. 7 days of abstinence leads to a 4-fold increase of cell formation. After 6 months of abstinence, there is a significant tissue volume increase. Although alcohol consumption causes morphological changes to the brain in numerous ways, upon abstinence, the brain is capable of regenerating all that it has lost and reverses the effects of alcohol. It is understandable if abstaining is difficult because the brain has morphed into being dependent on alcohol. But remember that you can move forward. No matter how many steps you have taken back because of alcohol, you still have all these steps you can take forward. You've taken your first step by watching this video. Now ask yourself, what will be my next step?